So now we are discussing the characteristic X-rays. So simply in the characteristic X-rays, here this is the atom and these are the different shells which we call it as a K shell, L shell, N shell and N shell and so on. Here. So if we say that the incoming electron, which is high energy electron, whose energy is kilo electron volt, is colliding with the electron in the K shell. If the energy of this electron is equal to the binding energy of the electron in the K shell, then there will be a chance that in the K shell electron is emitted out. The deficiency is filled by the L shell. So by emitting the photon, we call it as a K alpha. So this is known as a L. So if the deficiency is filled in the K shell by the L shell electron, so the emitted photon is the X-ray photon, we call it as a K alpha. K alpha is the characteristic X-ray of the K series. Similarly, if the deficiency is filled up by the N electron, if the N electron jumps directly to fill up the deficiency in the K shell, we call this photon is K beta. If the deficiency is filled up by the not M but N electron, so here the photon which is emitted out is the K gamma. So this is the K alpha, K beta and K gamma is the series of the X-rays, which we call it as a K series. Agar if the electron is emitted out from the L shell, then the deficiency can be filled by the N. We call it as a L alpha. Alpha means next. Beta means not next but after next. So this is called L beta. Similarly L gamma. So this is known as a L series. So here the characteristic X-rays of K series is much energetic as compared to L series because this is totally dependent upon the energy difference of the two levels, and energy difference of these two levels is larger as compared to this L series level. So this is the characteristic X-rays. It means this is the discrete packets of energy, and this discrete packets of energy is a high energy photons and we call it as a X-rays. So now it means here the emission of the electron from the K series, L series or N series is totally depending upon the energy of the incoming electron. If the energy is equal to the binding energy, then it emits out. Otherwise L, then otherwise M and so on. The second thing is that this is the atom which has a certain Z value. Z value is known as a charge value. Z is the charge number. It means number of protons in the nucleus or number of electrons revolving around the nucleus in the orbitals. So here we have to look at what is the relationship between the frequency of the emitted photon, because when the photon is emitted, its frequency is h nu. And this h nu is the energy difference of two levels, final minus initial. Emitted photon whose frequency is equal to this. This can be written as hc over lambda is equal to ef minus ei, finals minus initial. This which we have seen in the Bohr's calculation, Bohr's model for the hydrogen atom. Similar quantum theory is applicable over here. The photon which is emitted out must be equal, its energy must be equal to the energy difference of the two levels. So now we have to look at what is the Moseley law. So the Moseley law, it gives the relationship between the frequency of the emitting line and the atomic number. So we are discussing Moseley law. What is the Moseley's law? So it gives the relationship between the frequency of the emitting line and the atomic number. So now we have to look at the nu, which is the frequency, is equal to A, which is the constant, and Z minus B square. This A is the constant of line. This line means the transition lines. This K alpha is the transition line. इसकी a constant value है. A is some constant factor of the line. And B is also constant. This is known as the characteristic constant of the particular series. Characteristic constant of particular series. Characteristic constant of particular series, and sometimes it is called the screening constant. It is also called screening constant. Screening constant, आपको पता है screening constant tells us the how the material is to be neutralized. तो यहाँ पे अगर आगे देखें कि if we look here, if we look here, we know that by using Bohr's model, from the Bohr's model, the energy E is equal to minus 2 pi square m e raised to power 4 z square upon n1 square h cut square into 1 upon 4 pi epsilon naught whole square. This is the energy of the first level. Similarly, energy of the second level is E2 is equal to the same minus 2 pi square n e square n e power 4 z square upon n1 square h cut square into 1 upon 4 pi epsilon naught whole square. This is the Bohr's model. If we say that These are the two levels. Its energy is, let's say, this is N2 final, this is N1 initial electron dx side. H nu is equal to E2 minus E1. What is E2? E2 is equal to this. This negative sign shows that the electron is bound with the nucleus. Similarly, what is E1? E1 is equal to this. And this whole thing is constant, and sometimes we call it as a Rydberg constant. So here, in the case of, let's say, when we are considering the effect of electron, which is screen out the positive charge of the nucleus and reducing by the value of Z to Z minus B, we can rewrite according to the Moseley law the Z is changed by Z minus B, and this B is the screening constant. So in the case of X-rays, this B has a certain value which we call it as a screening constant value. Here, this Z is replaced by the Z minus B, and this is for the heavier atom and this is for the hydrogen atom. These two equations, E1 and E2, this is only for the hydrogen atom. And this Z minus B, Z is replaced by Z minus B, is for the other atoms. So now here, and B is known as a screening constant. Here, if we substitute these values, E1 is equal to the same equation, only Z is changed by the Z minus B. So here, this is minus 2 pi square m e raised to power 4 Z minus B whole square. This is E1, so therefore it is B1. Upon N1 square, H cut square into 4 pi epsilon naught whole square. Similarly, E2 is equal to minus 2 pi square m e raised to power 4 Z minus B2 whole square upon N1 square H cut square into 1 upon 4 pi epsilon naught whole square. This Z is replaced by Z minus B here in both equations. So now H nu, which is the energy of the emitted photon, H nu is equal to E2 minus E1. So therefore, the term becomes, if we substitute these values, this is the constant, this whole thing is the constant. So constant can be taken out from the both terms. So this is equal to minus 2 pi square m e raised to power 4 upon n upon h cut square into 1 upon 4 pi epsilon naught whole square. This is the constant. So here the remaining term is Z minus B1 whole square upon N1 square. Here Z minus B2 whole square upon, this is N2 square minus Z minus B2 whole square upon N2 square. So now we can rewrite it as if we look here, delta E is equal to this. So H nu for, let's say, N1 is equal to 1 and N2 is equal to 2. It means the electron jumps from N1 and this is N2. So N1 is equal to 1 and N2 is equal to 2. Electron jumps over here to imitate out the photon. So as a resultant, the nu is equal to 2 pi. This gives you the K alpha series. This is the K alpha series. So as a resultant, nu frequency या h nu is equal to here. ये आपके पास है h nu is equal to this relation. तो यहां से अगर आप ये देखें कि this B1 or B2 is approximately equal to B. यहाँ पे हम कह देते हैं कि B1 की वैल्यू और B2 की is approximately equal to B कह देता हूँ, because the screening factor of the both level is almost same. This is the screening factor for this B1. This is the screening factor for B2. So almost the same. So we say that the B1 and B2 is approximately equal to same, and which we call it as a B. So this h nu is equal to minus अगर मल्टीप्लाई कर देते हैं तो उस तरफ आ जाएगा. तो this becomes a 2 pi square n e raised power 4 upon h cube. This is h. This is not the h cut. This is h cube. This is not h bar. So this is h cube. This is h square into 4 pi epsilon naught whole square. This becomes z minus b1 means z minus b whole square, and this is 1 upon 1 minus 1 upon 2 square means 4. So this is 3 by 4. So we write a term here, the 3 by 4. So here the term is 3 by 4. So h can be cross multiplication. This gives you h cube now. So this is the frequency. Nu is equal to some constant factor here. This 2 is constant, pi square is constant, m is power 4 is constant, h cube is constant, 4 pi epsilon naught whole square is constant. So everything is constant. So only the term, which is the remaining term, is equal to the 3 upon 2 z minus b square. So here, this can be written as r into c. This is equal to r into c into 3 by 4 z minus b square. Because r is equal to, which we call it as a Rydberg constant, is equal to 2 pi square n e raised to power 4 divided by h cube into c 4 pi epsilon naught whole square. If you compare this both, so only the c is extra here, so the c can be multiplied over there, so the remaining thing is the same here. So this is therefore nu is equal to rc 3 by 4 z minus b. So here from this equation, nu is equal to 3 by 4 rc into z minus b whole square. This 3 by 4 rc is again constant. 3 by 4 is constant, rc is a constant, and 3 by 4, this comes out from the line, and this is for the Lyman series. This is for the Lyman series, this is for the K alpha. So this 3 by 4 is the constant term for K alpha, and we call it as a A. A is constant. So therefore, this frequency nu becomes A z minus b whole square. So this is the proof of the Moseley law, that the frequency is directly proportional to the square of the charge number. The frequency is equal to, this A is constant, which depends upon the line, which depends upon the characteristic line, or which here we have a K alpha. अगर यहाँ पे k बीटा देंगे, k गामा देंगे तो the value of a will be different. So the value of a is totally depending upon the line, depending upon the characteristic X-rays. If it is k beta, the a is different. If it is k gamma, the k is different. So for example, इसको समझने के लिए आप एग्जांपल कर देते हैं. Let's say here nu is equal to a z minus b whole square. This is the Moseley law. The frequencies depending upon the z number through this relation. For example, for k alpha, for k alpha line, a is equal to 3 upon 4 RC. R is the Rydberg constant, and B screening constant is 1. Let's say B is 1. And for L alpha, this is for K. For L alpha, so L beta, A is equal to 5 upon 36 RC, and B is equal to 7.4. These two are the screening factors. These are coming out from the data. अब ये दो एक्सरेज हैं. अब दो एक्सरेज हैं फॉर दी के अल्फा एंड के बीटा. अगर आपको इसकी फ्रीक्वेंसी अगर नोन है तो यू कैन फाइंड आउट द एलिमेंट. If the element is known, you can find out the frequency. The beauty of this relation is that if the element is known, element means Z is known, then you can easily find out the nu. This A and B are known things. These are the constant factors. But if the frequency is known, yeah, wavelength is known, because nu, the frequency is not known, but wavelength is known, because nu is equal to C over lambda. It means if the lambda is known, so then if the lambda is known, then again you can find out the unknown material. Okay, which is the unknown material? आप unknown material भी find out कर सकते हैं. For example, इसको समझने के लिए अगर हम एक example कर लेते हैं, तो it will be easier for you to calculate. Let's say if a series limit of the polymer line in the hydrogen atom, या इसको आप for example, let's say if k alpha radiation आप unknown भी मेजर कर सकते हैं. Let's say यहाँ पे एक प्रॉब्लम करते हैं तो इजी हो जाएगा. Here if k alpha radiation, if k alpha radiation of molybdenum, molybdenum का Z जो है वो 42 है, has a wavelength lambda is equal to 0.75 angstrom. Calculate the corresponding radiation coming out from the cobalt. Calculate the corresponding wavelength from cobalt. कोबाल्ट में से जो वेवलेंथ मिलेगी वो कितनी होगी, which you have to calculate. और कोबाल्ट का जो Z है वो 27 है. Z of the cobalt is 27. आपको पता है कि nu is equal to A Z minus B whole square. This is the formula. और corresponding line corresponding line कौन सी है? K alpha. So for K alpha, A is the same and B is the same here. Let's say this is for cobalt, or if you, and this is for molybdenum, which is again A Z minus B whole square. अगर इसका रेशियो में निकालो तो दे विल कैंसिल ईच अदर. इस फ्रीक्वेंसी को अगर वेवलेंथ में मैं कन्वर्ट करूं तो क्या होगा? दिस इज इक्वल टू 1 अपॉन lambda of cobalt and this is 1 upon lambda of molybdenum because frequency is reciprocal of molybdenum. ठीक है जी. तो इसको मैं इस तरह भी लिख सकता हूं कि wavelength of cobalt is equal to over the wavelength of the molybdenum is equal to Z of molybdenum minus B divided by Z of cobalt minus B. B is the same for both. Let's say मैं कह देता हूँ B की वैल्यू क्या है? B is equal to 1. यहाँ पे 1 आता है. अब यहाँ से अगर आप ये देखें कि Z of the molybdenum which we have 42 minus 1 divided by 27 minus 1. इसको आप निकाल के if the K alpha is of the molybdenum is given, you can find out easily the wavelength using calculation. So this is the simple formula. You can calculate easily. So some of the problems I will give you in an assignment. So here is the Moseley law and characteristic X-rays.